Hello dear students, welcome to Tejama YouTube channel. So in this video we are going to discuss about a new topic in this series, that is KCET 2027 from the chapter electric charge and fields, that is electric field due to dipole. What is a dipole? Here it is given the definition for electric dipole, that is a pair of equal and opposite charges separated by small distance is called an electric dipole. For example, you can take H plus separated by Cl minus with a distance, right? So you can represent it by a positive charge and a negative charge separated by distance 2a. So this gives you a dipole. Okay, so what is dipole moment or electric dipole moment? So it is a product of dipole length. So this 2a is called dipole length. The distance between the negative charge and positive charge is called dipole length. So if you multiply this, the product of dipole length and magnitude of any one of the charges, maybe positive charge and negative charge, because both are similar but opposite in polarity, if you multiply that, you will get P is equal to 2aq. P is called electric dipole moment, 2a is the length, into charge will give you electric dipole moment, and it is a vector quantity. It is a vector. So if it is a vector, there should be a direction, right? What is the direction? So direction of electric dipole moment is from negative charge to positive charge of the dipole. For example, if I consider this is the dipole, this is positive charge, this is negative charge, dipole moment is represented from negative to positive direction. So what is the significance of electric dipole moment? It represents the strength of electric dipole. The significance of electric dipole moment is it represents the strength of electric dipole. And what is the SI unit? Here it is given the charge into length. So for charge it is coulomb, and for distance it is meter length. Okay, na? Next, we have the derivations for electric field along the axis and along the equatorial. For that, please refer the link that is given in this description, where I have derived the expression for all the terms that is required in the 5-mark derivations. All of them I have done and uploaded in the YouTube. That link I will give in the description. Please follow it. You will get the detailed explanation it. Here I have given the final formula. Electric field intensity at any point on the axial line at a distance r from the center of dipole is given by E axis is equal to minus 2p divided by 4 pi epsilon naught r square minus a square whole square. Okay, if you simplify it, you will get this formula. E axis is equal to 1 by 4 pi epsilon naught 2p divided by r cube. And we have similarly the electric field intensity at any point on the equatorial line at a distance r from the center of the dipole is. So that is this is the general derivation, that is E equatorial is equal to 1 by 4 pi epsilon naught p divided by r square plus a square 3 by 2. Actually here we will get a minus sign also. In vector form we will get a minus sign with minus. That's why if we compare E axis with E equatorial, this E naught I will write it as E equatorial. So if you compare, here 2 is there, here E equatorial, right? Here 2 will not be there. E axis we have 2p, here only p will be there. Here minus is there, here minus is not there. So that's why we'll write E axis is equal to minus 2 times E equatorial, or in scalar form it is just E axis is equal to 2 times E equatorial. Please refer the video link that I have given in the description for the derivations, E axis and E equatorial, which very important. 2 5-mark derivations are there for board level. Okay, derivations very important. Next, we have the derivation for torque acting on a dipole placed in uniform electric field. So let's consider here. I'll consider the uniform electric field. Okay, and I'll place a dipole in it. Let's consider here we have a negative charge and here we have a positive charge. These two are separated by, okay, some distance, that is 2a. So here positive charge experience force in this direction, that is F is equal to plus Q into E. Negative charge experience force in this direction, that is F minus is equal to minus Q into E. So if we take the net force experienced by the dipole in uniform electric field is QE and negative charge is minus QE, that will be 0. Do remember, the net force acting on the dipole placed in uniform electric field is 0. But what about torque? So if we consider here the perpendicular and this is the base, this is theta, this perpendicular will be 2a cos sin theta and base will be 2a cos theta. So this perpendicular into force QE will give you torque, correct? No? So torque is equal to force is P, perpendicular distance is 2a sin theta. Here, sorry, not P, it is QE. What is 2a into Q? Dipole moment. That is P sin theta. Since we know that dipole moment is given by 2aq, in place of 2aq I'll write P. So this will be the torque, and in vector form it is written as P cross E. Okay. So if I do some external work against this torque, because here the dipole moment in this direction, so because of the force experienced by dipole, it rotates clockwise. Okay, just a minute. Yeah, it rotates clockwise, but I will do some work against it. So work done to rotate the dipole from theta 1 to theta 2 is given by minus P. I am rotating it from theta 1 to theta 2 is given by cos theta 2 minus cos theta 1. Okay, and this will be, this work done is stored as potential energy. Potential energy. Now, sir, what if theta 1 is 90 degree? So we want, theta 2 is theta. Cos 90 is 0. So we'll get U is equal to minus PE. In place of W, I'm writing U. That is equal to cos theta. Because cos theta 1 will be 0 because theta 1 is 90 degree. Okay, this is one. Why I have given this here is based on these two you may get competitive level questions. Now look at this. Here we have tau is equal to P sin theta. U is minus P cos theta. Divide the magnitude of tau with magnitude of U. So we'll get P sin theta divided by, don't take minus sign, just take the magnitude, P cos theta. So sin theta by cos theta is tan theta. Tan theta is equal to tau divided by U. This is also very important result. Okay. Write down all this. I'll move on to the next page. See, here it is given. Potential energy. Okay, minus PE cos theta, that can be written as P dot E. Potential energy of the dipole in the uniform electric field is given by this. If theta is 0, then cos 0 is 1. The potential energy will be minimum. If theta is 90 degree, potential will be 0. Okay. So if theta is equal to 0, potential energy is minimum. This is called stable equilibrium. Do remember, this is very important. Stable equilibrium. If theta is 180 degree, then U is equal to P, because cos 180 degree is how much? Cos 180 degree is minus 1. Do remember one thing, that is cos n pi in general is given by minus 1 power n. and sin n pi is equal to 0. Correct? No? Do remember these two. You can use this results in your competitive exams directly to find the value of cos n pi and sin n pi. N value is an integer. It may start from 0, 1, 2, 3, 4 like that. So 0, if you substitute cos 0 is 1, sin 0 is 0 like that. Then we have at cos 180 you will get plus p, because minus minus will get cancelled. Here the potential energy is maximum. This is called unstable equilibrium. These angles will be asked. Then work done in rotating the dipole from position p, theta 1 to theta 2 is given by p cos theta 1 minus theta 2, or this can also be written as minus p cos theta 2 minus theta 1. If you multiply theta 1 inside, you will get cos theta 1 minus theta 2. Same thing I have given, right? Look at this, cos theta 2 minus cos theta 1. Okay. Let us solve few MCQ questions based on this. First we have an electric dipole is placed in non-uniform electric field. Then it experiences, here it is given non-uniform electric field. In non-uniform electric field, dipole experiences both force, non-zero force, okay, and non-zero torque. Therefore, both force and torque will be there. If uniform electric field is given, force will be 0. In non-uniform, this is for non-uniform. If in case you consider uniform, force will be 0, torque may not be 0. That is in case of uniform. Okay, this is about this. That's why option non-uniform, option C is correct. Then the ratio of electric field intensity at a distance on the axial line is equal to E axial line is equal to, sorry, they are not giving equal to, right? Sorry, the ratio of electric field intensity at a distance along the axial line to that at a distance on the equatorial line of sharp dipole is, we know that E axis is equal to 2 times E equatorial. So they are asking us to find the ratio of E axis to E equatorial. So E axis divided by E equatorial is given by 2 divided by 1. That is option B is correct. Direct question. No need of getting confused. Then, if the magnitude of intensity of electric field at a distance is x, magnitude of intensity of electric field at distant x on the axial line and y on the equatorial line on a given dipole are equal, then x is to y ratio is. So the magnitude of intensity of electric field at a distance x along the axial line. Let me take E axis. E axis at a distance x is given by 1 over 4 pi epsilon naught 2p by x cube. This is general formula. And E equatorial is given by 1 over 4 pi epsilon naught just p by, here E equatorial distance is given by y cube. They are asking us to find the ratio of x and y by giving the E axis is equal to E equatorial, or equal is given. So if I take this one is equal to this one, these two are equal, then these two will be equal. Yes or no? This one and this one are A. So right hand sides are equal. Let me equate. So what happens? 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught get cancelled. PP get cancelled. You'll be having 2 divided by x cube is equal to 1 divided by y cube when you equate E axis to the equatorial. I need to find out x by y. So I'll take x cube by y cube is equal to 2. Then from that you'll get x divided by y is equal to cube root of 2. So that's why option D is correct. Okay, option 2, D is correct. That is cube root of 2 is to 1. Next, moving on to the direction of electric field intensity at any point on the equatorial line and the dipole of an electric dipole is. So if you consider the electric field due to dipole along the equatorial, how does it look? So if you consider this is the equatorial, electric field along the equatorial, I need to draw a line here. Okay, here it is in this direction, E plus. This is E minus. Here dipole moment will be from negative to positive charge towards left. E plus will be upward, downward, and E resultant is right side. So the direction of resultant electric field at any point on the equatorial line of electric dipole is parallel but opposite to, okay, opposite to the dipole moment. That is anti-parallel to the dipole moment. Look at this. E resultant is opposite to dipole moment. Array, oh bicep. Okay, let me read like this. When I put this line, it will take us to the next line, next page. No problem. Okay. For a short dipole, the ratio of electric field at any point, this is any point on the axis, E axis, the ratio of electric field at a point on the, okay, this is, got it. Just a minute, let me read it once again. This is just the typing mistake. Okay, for a short dipole, the ratio of electric field at point P on the axis, okay, on the axis divided by, and point Q on the equatorial line, both are at the same distance, is given by E axis divided by E equatorial. Just now we have learned that is 2 divided by 1 from the center is. So 2 divided by 1 is there in option 1 and option 2, but from the, and the fields are in the same direction. No, the fields will be in opposite direction. Along the axis, if you consider minus plus here, electric field along the axis will be away from positive charge, E resultant along the axis. But E resultant along the equatorial will be towards left. E equatorial will be always in the opposite direction of dipole moment. Here E resultant will be in the direction of dipole moment, so there will be 180 degree. So that's why option C is correct. Next we have electric field due to dipole at a distance on its center varies as, from its center varies as. So electric field due to dipole is inversely proportional to r cube. That's why option C is correct. Two charges plus q and minus q are placed at, so if I take the Cartesian coordinate system, this is 0, 0, x-axis it is given, right? Let me consider it as 0. So on negative minus a there is a charge, plus a there is a charge. This length is 2a. The dipole moment of the vector is, sorry, dipole moment, yeah, of the dipole is, we can write P is equal to 2aq in vector form. Since the dipole is directed from negative to positive charge, that is towards the positive x-axis, 2aq I cap, 2aq I cap. Electric dipole P is in stable equilibrium in the uniform electric field. Stable means theta should be 0 degree. Then the angle between the P and E is, so option A is correct. Then for electric dipole in a uniform electric field, the net force is always 0 because here it is given uniform electric field. Clear? Next, an electric dipole of dipole moment P is placed normal to the line of force and the electric field E. So normal means here electric dipole moment P is placed normal to the line of force. So that is line of force means electric field. Let me take, there is a dipole here and we have electric field. I need to erase this. Let me draw a new diagram. Yeah. So let's consider here we have electric field, uniform electric field. So dipole is placed normal to it. Here we have positive charge, here we have negative charge. Dipole moment will be upward and electric field is like this. So they're asking us work done in rotating or deflecting it through an angle 180 degree is. So it's already the dipole moment is placed normal to the electric field. So theta 1 is 90 degree. So theta 2 will be 180 degree. So the work done they're asking, not torque. Work done is given by P cos theta 1 minus cos theta 2. Correct, no? So work done is equal to PE cos theta 1, cos 90 degree is 0 minus cos 180 degree is minus 1. So minus of minus 1 is 1. So you'll get PE as your answer. Option 1 is correct. Clear? Okay. Let us move on to the next one. A dipole is placed at an angle theta is equal to 30 degree with the field E is equal to 2 into 10 to the power 5 Newton per Coulomb. It experiences a torque of tau is equal to 4 Newton meter and dipole length is given, you can take it as 2a, 2 centimeter, 10 to the power minus 2 meter. The charge on the dipole is, since torque value is given, you can write it as P sin theta. So that is equal to P is 2aq, 2aq, 2a value is given, q need to find, theta is given. So q is equal to tau divided by 2a sin theta. Let me substitute the values here. Torque is 4, 2a is 2 into 10 to the power minus 2, sin 30 degree is 1 by 2. 2 to get cancelled, you will get 4, what else is 10 to the power 5. Oh my god, something is missing. 2a into e is there, into e, into e, that is 4 divided by 2a, that is 2 to get cancelled, into 10 to the power minus 2 into 2 into 10 to the power 5. So 2 ones are 2 twos are. So Q is equal to 2 divided by 10 to the power 3. That is 2 into 10 to the power 3 comes to numerator, 10 to the power minus 3 coulomb. That is 2 millicoulomb. Option A is correct. E was missing here. Okay. Next, potential energy of electric dipole in uniform, dipole is maximum when the angle between P and E is, so potential energy is given by minus P cos theta. If cos theta is 180 degree, so cos 180 theta is 180 degree, cos 180 is minus 1, minus into minus plus, you will get PE. So at 180 degree, the potential energy will be positive and maximum. So work done in rotating the dipole from position of stable equilibrium, that is theta 1 is equal to 0, to unstable equilibrium, that is theta 2 is equal to 180 degree, is given by, so work done is equal to plus PE cos theta 1 minus cos theta 2. Work done is equal to P is how much? Don't know. E don't know. In the options also P is given as it is. Cos theta 1 is cos 0, that is 1. Cos 180 is minus 1, minus into minus plus 1. You will get 2 P. Okay. So because cos 180 degree is minus 1. Next, when the dipole is rotated from an angle theta 1 to theta 2 in the uniform electric field, work done is cos theta 1 minus cos theta 2. P cos theta 1, that is option 1 is correct. Correct, no? Sorry, just a minute. Yeah, correct. Next we have electric dipole moment P is released from rest in uniform electric field at 90 degree. Its kinetic energy when it reaches 0 is. So here when the dipole moment P is released from rest, so by the time it reaches 90 degree, so their work done is equal to PE cos released from rest in uniform electric field at 90 degree, cos 90 minus 0. Okay, kinetic when it reaches 0 degrees. So theta 1 minus theta 2, that is PE cos 90 is 0, minus cos 0 is 1. So it will be minus PE. So the magnitude is PE. So option A is correct. The SI unit of dipole moment is coulomb meter. Option B is correct. If the electric dipole is moved from lower potential to higher potential region without changing the orientation, then its potential energy increases, because we may have to do some external work to move it from lower potential region to higher potential region. So work done increases, therefore potential energy also increases, because we are pushing the dipole against the electric field. So the electric potential at a point on the equatorial line of the dipole is electric potential any point on the equatorial line, it is 0, because theta will be 90 degree. Electric potential due to dipole is given by 1 by 4 pi epsilon naught. Actually this is from the second chapter, but I'm solving it here, no problem. Cos P cos theta divided by R square. So here theta is 90 degree, cos 90 is 0. This is from the second chapter, electric potential capacity, no problem. So the answer is 0. Then electric dipole, so consider this as your homework. I'll give the hint. Electric dipole consists of two opposite charges, q1 and q2 is given. Q is equal to 2 into 10 to the power minus 6, separated by distance is given, that is 2a is equal to 3 centimeter 10 to the power minus 2 meter. This is dipole length. it is placed in uniform electric field, that is E is equal to 2 into 10 to the power 5. Find the torque, maximum torque, that is P into E. P into E is given, P is 2AQ into E. Q is given, 2A is given, E is given. Just multiply that, you will get the answer. Will you solve it? Yes, sir. Okay. Dipole is placed in a field such that the potential energy is minus P. So minus P, then the state is. So potential energy is minus P. Potential energy I will write it as U is minus P cos 0 is 1. So theta is equal to 0. That is stable equilibrium. Okay. So this is about this video. Thank you so much. If you feel the content is useful, please share it to your friends and tell them to subscribe. We'll meet you in the next video. Till then, take care. Bye bye. Thank you.